This is section 8.3 on the product and quotient theorems. Before we go on, I just want to make sure that you understand what a complex number is when it's written in trig form. Suppose that we have 2 CIS 30 degrees. If we draw this on the complex plane, we have an angle that's 30 degrees, and then we have the length of the vector, which is 2. R describes the length of the vector, and R is always positive. The angle will take care of if you have it going into another quadrant. So for the trig form, R is always going to be positive. You can also think of R as the absolute value of that number. So the absolute value of this number is 2, because the distance from the origin to that terminal point of that vector, that distance is 2. And remember that the absolute value of a number is the distance that number is from the origin, the same thing as if you're just working with a real number. The same definition applies to complex numbers. Let's go to the products of complex numbers. If we want to multiply two numbers together that are written in trig form, and if these are the two numbers, then you would multiply the r's together. So multiplying these numbers, you first multiply the r's together, and then you add the arguments. And the arguments are what you're taking the cosine and the sine of. And this is the way that we can write it in compact form. That is, to multiply complex numbers in trig form, multiply their absolute values. And that means to multiply the r's together, and then add their arguments. That means that we're adding the thetas. If we go to the next page, 8-13, for the quotients of complex numbers, you can probably guess what we're going to do. If we're dividing two complex numbers, then you would divide their absolute values and you would subtract their arguments. And this is the compact form. So that is, to divide complex numbers in trig form, divide their absolute values and subtract their arguments.